Hello everyone. Today let's solve the problem road optimization. Right. So you can read the entire question. They have also mentioned the input with desired output. So that also you can see. And I'll just simplify or summarize the problem for you so that it is easy to understand. And also we'll discuss the approach first and then we'll go with the solution. So what the question says here. So the problem involves optimizing the time taken to travel between two cities on Mars. The time taken to travel between two cities on Mars. Two cities, right? Two cities. I'll just write 2C. The time taken to travel between two cities on Mars with speed limits indicated by the road signs. So our main goal is to minimize the travel time by removing up to K road signs. So here I'll just give road signs RS. So we have to minimize the travel time by removing the K road signs. That's what we have to do here. So that's what we have to do, except the one at the start. The start road sign we shouldn't remove. Let's consider start as 1. Just for the example sake, I'm taking 1. It is not 1, or you can take yes as well. The starting one. So suppose if this is start, we should ignore this one and we have to minimize the travel time by removing other K road signs, right? This is K road signs we have to remove. And the main challenge is to find the optimal way to remove these signs to reduce the total travel time. What we have to do? We have to find the optimal way to remove these signs to reduce the total travel time. That's what the question says here. I hope the question is clear. Let me remove this one. So what will be the approach? So as usual, first step is that we will go with input handling. So first step is, if you have followed the previous videos, you will be knowing. So first step will always be input handling. So after input handling, the second step is, here we'll go with the input parsing. Input parsing is related to the node actually. So the problem will be solving with the JavaScript or Node.js, right? So here this one input parsing is related to node. So we start by reading the number of signs n. Number of signs n. This one number of signs I'm taking n. The total distance will be L. Number of signs will be n. The total distance will be L. And the number of removable signs is K. They have clearly mentioned in question also. If you have read that one properly, I have explained the question as well. I had summarized the question and explained the question as well. This is nothing but this K and the number of removable signs K. Next, we will read the coordinates of the sign. This one, coordinates of the sign. When I say coordinates of the sign D, and the corresponding this one, speed limit. Corresponding speed limit to this one will be A. So this one, initialization. So sorry, input parsing. So while we write the code, you will understand this step. For now, you can just ignore or just listen to this one. So while writing the code, you will get to know about the input parsing, right? The third step, so this will be the core logic or the main logic. So what we'll do, we'll be making use of dynamic programming for this particular question. So what we will do here, we'll set up the dynamic programming. Nothing but we'll be making use of the DP table where 2D DP table. So 2D DP array. This will be DP of I and J. So where DP of ij represents the minimum time to reach the ith sign after removing the j signs. We have to remove certain signs to we have to remove certain signs, right? The minimal minimum time we have to calculate. So why we are making use of the dynamic programming table, DP table, because a DP of ij represents the minimum time to reach the ith sign after removing j signs. This is what the third step says. After this one, we will go to the fourth step. So after this one, we'll go with the iteration as usual, right? So nothing but we have to fill the DP table. First, we'll initialize the base case. First, we'll go with the base case. So what will be the base case? When no signs are removed. So you cannot remove any sign, then that will be the maximum, minimum time will be what we have traveled itself, right? So that is one thing. That will be our base case. Next, for each segment of the road, we have to calculate the minimum time it takes to travel based on the remaining signs. This is important. Again, I'll tell, for each segment of the road, what we are doing, we are calculating the minimum time that it takes to travel based on the remaining signs that that we have, right? Finally, after this one, I hope fourth step is clear. After this one, fifth will come to final step or the fifth step. Finally, we will find the minimal time from the DP table, ensuring that we have considered k signs removed. We have removed the k signs. We are by removing the k signs in the DP table, we will find the minimal time, right? So this is what the approach is. So let me delete this one and let's start writing the code. So we'll get to know better. So first, as usual, we'll go with the input handling. We'll listen to input and process the data. First, what I'll do, I'll just give, just give me a second, process dot standard input dot resume. This is one thing. Again, process dot. Let's make use of the set encoding and set this one to UTF-8. So next step is, we'll store the input as the single string. Also, we will track the current line for the reading input. So I'll just give let, as usual, input string, empty string. This one, let current line, I'll just set this one to 0. Next step, we'll capture the input data. We'll be making use of the event listener, right? Process dot standard input dot on. So here data input standard input. So here this will be, let's append the input string to input stdin. Next, I'll copy the same thing and make the necessary changes. Let me come here. Let me paste it over here. Next step is, once the input ends, we will once the input ends, we have to process the data, right? For that, so here we have already processed the data. So I'll just take end here. Let me remove this one. Also, we are not appending anything here. So this has to be input string. So we need to remove the white spaces or the spaces. I'll just make use of the trim. Here we need to read all the lines of the input. I'll use /n. Again, let in all the lines of the input, we have to remove the white spaces, right? For that purpose, I'll just make use of map string here. This has to be string dot trim. This is fine. So next line, so we have to call the main function as well. We have not yet written the main function here. We'll be writing the main function in future. So after writing the main function, let's come here and call the main function, right? So next we have to read the individual lines, right? After reading the first line, we have to read the second line. We have, after reading the second line, third line, fourth line. So for that purpose, we are having the multiple lines of input. So in the question they have mentioned. So let me make use of the read line function for that. I'll just give read line, return. This one has to be input string of current line. We are incrementing to the next line for that purpose. Next, let's write the main function. Nothing but here within the main function, we always write the main logic or the core logic, right? So that is what we'll be doing. Just give me a second. First, what we will do, we will read the first line of input. Nothing but number of signs n, distance L, and also k, maximum removable signs. Nothing but k, n, L, and k. So you can individually assign this one as well. I'll just make use of the destructuring operator. So n, L, and k. Let's assign this one too. We have to read this one, right? Read line, I'll just make use of. Next, after reading, if there are multiple numbers, we need space, right? In the same line, if we have multiple numbers and those numbers differ, we need space, right? For that purpose, I'll just make use of split. So here, let's leave the space. Also, let's map the type number. This has to be number, right? Number type. So I'll just make use of the number. Here, you can make use of the big int as well. If you are going with the large numbers, if you are dealing with the large numbers, or if the input contains the large data, if we are having the large inputs, then we can go for big int. So I'll just go for the number. So if it doesn't work out, then let's go with the big int, right? So, and next step, we will read the position of the signs, nothing but di and the speed limit ci. Here, di is nothing but the position of the signs, and ai is nothing but the speed limits. I'll just give let d equals, let me copy this one, same thing here. Let me copy this thing. I don't want to type this one again. Let me copy paste this one again. Let a equals, me paste the same thing. We are reading, splitting and mapping of the type number. Next, after reading the position of signs and speed limits, we have to add the city, nothing but the final position as a sign at position L with the speed limit 0. So for this one, we can make use of the push, right? We are adding at the end. So what we are doing here, we are appending the total distance as the last position. Also, we are appending the speed limit at 0 at the last position. So to append the total distance and speed limit at the last position, we can just make use of the push, right? I'll just give push of L, also a dot push of 0. This is one thing. So next, let's initialize the DP table with the infinity values. So how can we do that? I'll just give DP equals array from length. Let me take the length n plus 1 here. So this is fine. Then, sorry, did I miss anything? Yeah. This one has to be, let's fill the array with n and, array of n, and let's fill this one with positive infinity. Positive infinity. This is fine. Next, after initializing the DP table with the infinity values, let's move on with the base case. While explaining the approach, I said we spoke about the base case, right? Base case is nothing but time to reach the each sign without removing any signs. We are not removing any signs, but we are when we don't remove any signs, we need to calculate the time to reach each sign, right? So for that, I'll just be making use of the for loop. For let, I'll just give index equals 0. I should have just took I. This is fine. Increment index. So next, this is formula, nothing but time equals distance into speed. So I'll just give dp of index as well as 0. This is nothing but d of index also into a of 0. Right. So let's fill the DP table by iterating through the signs. We have initialized now, and also we have we went with the base case. We have finished that one. Next, we have next what is left. We have to go with the iteration, right? So let's fill the DP table by iterating through the signs. So this will be, again, I'll just be making use of the for loop. I'll be quick here. Let index equals 1, index less than n, index, let's increment the index. This is fine. Next, again, for, I'll just make use of the variable name change. Just initialize this one to 0. Change less than index. Also, let's increment the change. This is fine. Next, let's update the DP table for each possible combination of the removed signs. Again, I'll just make use of the for loop. This is simple. So iterating through everything. So I equals, I'll just give index plus 1. I should be less than or equal to n. Also, let's increment the I. So next step after doing this, we have to calculate the time if we move from sign index to sign I. So this for this, let's consider the temporary variable. So I'll just consider temp dp of this will be index and change also plus d of I minus d of index into a of index, right? So this is one thing. Next, if this time is less than the current time in dp, then we will update. While I was explaining the approach, I said, so when the time is less than the current time, then we are going to update the dp array. So that's what we'll do. For this is condition, right? For conditions, I'll just make use of the if. So if temp less than, this has to be dp of and change. So change plus 1, it has to be, right? Sorry. dp of I change plus 1, will set this one to temp, right? That's what we are doing here. So this is fine. Else, what we will do? We will optimize to stop further checks. So I'll just give break over here in simple terms. So this is fine. Next, here, what we need to do? Somewhere I did wrong here again, I think. It is fine. So what is the answer mainly? The answer is the minimum time after removing up to k signs. So how can we write that? This one, after removing the k signs, we have to find the minimal time, right? I can just take a result here. Result equals minimum. For minimum, I'll just take math.min. Spread operator, let me make use of the spread operator. dp of n, right? So let's slice till n minus k minus 1. This is fine. We are considering up to k removed sign. That is the reason it will be n minus k minus 1. So this is fine. After this, let console log result, right? So somewhere I did mistake, that braces. This is fine. Let's call the main function. So here we finish the main function, right? Let me come here. This is it. Next, let me copy the input. So we have to get the output 47, right? So infinity 47. Why this is happening? So somewhere I have missed this one, I think. Braces. So 47 answer is correct. So we are getting infinity 47 4 times. What is wrong with this? Let's check what is wrong. So what I have done here is, after this loop, I had to close this one here itself. So I'll just copy this one. Let me cut this one from here. After this, let me close the bracket here. So let me hit the run again. So now we are getting the output correct. So output is 47. So let's check for the second input. We have to get the output 38, right? So let me hit the run again. So we are getting 38 as output. So this code works. This code is working absolutely fine. So let me just give me a second. Let me come here. Let me click on submit code. Let me paste this one. This is problem C, right? Road optimization. So let me hit on submit. Let's wait for some time. So yeah, you can see here, this is the code is accepted, right? You can clearly see here. So this code works absolutely correct. So there was one mistake that I did here. instead of placing the braces here, I had to close the bracket here itself. So this was the that is the reason we are getting the wrong output. So now this code works absolutely correct. This is it. Thanks for watching, guys.